Hello everyone, myself Naina Shreyas. I am studying in Sri Venkateshwara College of Engineering. In this video, I am going to explain about how to do the conversion of NFA to DFA. The contents are what is DFA, what is NFA, the steps to convert NFA to DFA and the advantages and the example we can see in this video. The first we can see about what is DFA, deterministic finite automata or a DFA or a finite state machines that accepts or rejects strings of characters by placing them through a sequence that is uniquely determined by each string. The term deterministic refers to the fact that each string under each state sequence is unique. DFA doesn't accept the null move, that is, DFA cannot change state without any input character. The example of DFA: first design a DFA with 0 or 01, accept those strings which starts with 1 and ends with 0. This is a state diagram of DFA. It starts from the Q0, Q1, Q2. Q2 is the Q2 is the final state, and Q0 is the first state of the DFA. Next is NFA. NFA stands for non-deterministic finite automata. It is easy to convert an NFA than DFA for a given regular language. The finite automata are called NFA when there exist many paths for specific input from the current state to the next state. Every NFA is not DFA, but each NFA can be translated into DFA. For example, design a NFA with input alphabet 0 and 1 that accepts all the strings that end with 0 and 1. Q0 here the state diagram of the NFA. Q0 is a first state and Q2 is a final state which accepts all the inputs or the strings of the data. Next is conversion of NFA to DFA. We can see the steps how to convert from NFA to DFA. First step, convert the given NFA to its equivalent transition table. To convert NFA to its equivalent transition table, we need to list all the states, input symbols and the transition rules. The transition rules are represented in the form of matrix, where the rows represents the current state and the columns represents the input symbol and the cells represents the next state. Step 2. Create the DFA start state. The DFA start state is a set of all possible starting states in the NFA. In step 3, create the DFS transition table. The DFS transition table is similar to NFA's transition table, but instead of individual states, the rows and columns represent sets of states. For each input symbol, the corresponding cell in the transition table contains the closure of set of states obtained by following the transition rules in the NFS transition table. Step 4. Create the DFS final state. The DFS final states are the sets of states that contain at least one final state from the NFA. This is the example for converting from NFA to DFA. Here the Q0 is the first stage and there are three states Q0, Q1 and Q2. Q2 will be the final state and Q0 will be the starting state. We can see the construction transition diagram. Q0, Q1 and Q2 are the three states which has having in NFA to DFA. The transition table states are Q0, Q1, Q2 and the inputs are 0 and 1. First we have to see that Q0, where the Q0 is going through 0, that is self loop here in Q0, that is called Q0, we have written here. And next we have to see that Q1 where it is, and Q0 also has self loop of 0, so that we have written Q1 and Q2. Next we have to see that Q2. And this is a transition diagram for a DFA to. According to the transition table, we can see that Q0, there are different states, that is Q0, Q1, Q2, and similarly it is connected to the Q0 and Q1 and Q2, and it has been self loop. Here the final states are three. One is Q2, another one is Q1, Q2, and Q0, Q1, Q2. These are also final states. Here the 0 and 1 are the inputs. Q naught states are Q naught, Q1, Q2, where Q naught and Q naught, that is we should have to ignore because it has been self loop. Q naught, Q naught, we have to see that Q naught where it has transmitted from 0 to 1 and Q naught is self looped, so it is written as a Q naught. Next, Q2. We have to search for Q2 where it is from 0 to 1. It has been transferred. Next, it has transferred from Q0 to Q1. In one state, it has transferred from only in Q1. Next, we have to search in the states of Q0 and Q1. In that state, the 0 has been transmitted Q0, Q1, Q2. And in one state, it has transferred as a Q1 and Q2. And Q1, comma Q2, this is a, we should have to ignore this. It's supposed to be in the self loop, so that we have to ignore this. What are the advantages of NFA to DFA? Efficiency, simplicity, minimization, capability. Efficiency. DFAs are faster than NFA in terms of processing time and memory usage. This is because DFAs have a fixed number of states, whereas NFAs can have multiple transitions for a single input symbol for a given state. This makes it difficult to determine the next state of automation, which can slow down the processing time. Simplicity. DFAs are similar than NFAs in terms of numbers of states and transitions. This makes them easier to understand and implement. Minimization. Converting an NFA to DFA can help in minimizing the number of states in automation. This can be done by merging equivalent states in NFA. A minimized DFA is easier to understand and implement than a non-minimized DFA. Next is capability. Many algorithms and tools are designed to work with DFAs. Converting an NFA to DFA can make it easier to use these algorithms and tools. Thank you.